Okay, this is lesson 8.4, Laws of Logarithms. We're going to do this in 4 videos, one for each of the 4 laws. The way each video is going to work is I'll first start with the law and the example, at which point you may choose to continue watching for the proof of the law. However, you aren't required to reproduce the proof of any of the laws of logarithms, so it is an optional piece that you can choose to watch or not watch. The focus of the lesson for you should be on what the law is, how to identify when to use it, and how to use it. Okay, so the first law is for multiplication, and the way it works is that if you have 2 logarithms with the same base that are being added, you can rewrite those logarithms as a single log with the base that was shared by both logs by multiplying the inputs x and y to write it as a single log. Alternatively, if you have a single log with which the input is being multiplied or is a number that you can divide into 2 pieces, you could rewrite it as 2 logarithms. So when might this be useful? Well, it might be useful when, say, you have 2 logs that can't be evaluated evenly, or you can't get a whole number answer. For example, there's no whole number exponent that we can raise 6 to get 4, so this logarithm's answer would be a decimal. Same with our second logarithm. There's no value that we can raise 6 to get 9. So we could apply the law of logarithms to write this as a single logarithm, which might be able to be evaluated easier. So let's try it. We take our 2 logs that are being added and we write it as a single log with the same base, so 6, and multiplying the inputs 4 and 9. So I'm going to write that in brackets, 4 times 9, and 4 times 9 is 36. So we can rewrite that as a single log of 36 base 6. And now you may see that this can be evaluated evenly, because to what exponent do we have to raise 6 to get 36? Well, that's 2. And we can demonstrate that by using the definition of a logarithm, so rewriting it as a power. 6 to the exponent x equals 36. And if we rewrite 36 as a power with a base of 6, it would be 6 to the exponent 2. And if we equate the exponents, we've solved the logarithm. The other option is if you have, we'll call this an example, if you have a single logarithm, log of, say, well, let's just use the opposite example, 36 base 6, and you could split that into 2 logs. For example, we could choose to split this into any 2 factors of 36, so let's say 6 and 6. We could rewrite this the log of 6 base 6 plus the log of 6 base 6. Hey, and these evaluate quite easily. Log of 6 base 6 is 1, log of 6 base 6 is 1, 1 and 1 is 2. So we actually have the answer by going either way. There are some conditions on the laws of logarithms for multiplication, mainly that x, y, and a, so the inputs and our base, all need to be greater than 0, and a cannot equal 1. So it's at this point now that you may choose to turn the video off and move to the second law. If you'd like to see the proof, here we go. So to prove the law of logarithms for multiplication, we can take both terms on our right side and write them as a single variable. So I'm going to choose m and n for my variables. So we'll say let log x base a equal m, and we'll let log of y base a equal n. If we rewrite both of these as powers, we'd have a to the exponent m equals x, and a to the exponent n equals y. Now the law of logarithms says that if we're multiplying x and y inside a logarithm, we can split that into 2 logarithms. So what is x times y? Well, x is a to the exponent m, and y is a to the exponent n. And what happens when you multiply powers with the same base? Well, you add the exponents. So we'd have a to the exponent m plus n. Now, if we look at the left side says log of x times y base a. Well, what is x plus y? X plus y is a to the exponent m plus n. So we could rewrite that as log of a to the exponent m plus n base a. And now we have something interesting. If we look at our common properties in our first lesson, we have a power inside a logarithm that share the same base. So we can simply rewrite that as the exponent on those powers. Because the answer to the question, what exponent do we have to raise a to get a to the exponent m plus n? Well, it would be m plus n. And what is m plus n? M, from our initial definition, is the log of x base a. And what's n? N is the log of y base a. So there we've proven the logarithm, or we've proven, sorry, not the logarithm, the law of the logarithm, that the log of x times y base a, log of x times y base a, is equal to the log of x base a plus the log of y base a. Log of x base a, log of y base a. Okay, that's it for the law of logarithms for multiplication.